1.6 is solving inequalities, solve linear inequalities. What does the linear mean? Line, good. 1.6. Solve linear inequalities. Linear inequalities. Okay. A linear inequality in one variable can be written in one of the following terms where a and b are real numbers and a does not equal 0. So we're going to show you different ones. So a and b are real numbers. So you might have something that says ax plus b is less than 0. You might have something that says ax plus b is greater than 0. You could have something that says ax plus b is less than or equal to 0. And what's the fourth inequality? Yep, greater than or equal to 0. Those are all your options where a cannot equal 0 in this case. So I can't plug a 0 in for a on those equations. Those are pretty much the simplest form of linear inequalities. Okay, the graph of an inequality is one variable consistent of all points of the number line that represent the solutions. The solution of an inequality is in one variable is a value that when substituted for the variable results in a true statement. So when we go to graph linear inequalities, we are going to use number lines. And we're going to graph x is less than 2. Okay? How would I graph that? I'm going to put a number line. I'm going to put 0. I'm going to put some numbers, 1, 2, 3, -1, -2, -3. When it says x is less than 2, what does that mean? Okay, so I'm going to come over here to 2. Now, in the past, you have used closed and open circles, right? To do this, we're going to use parentheses and brackets. Okay? Parentheses go with less than or with greater than. Brackets go with less than or equal to or greater than or equal to. So when I come here, I'm going to put a parenthesis at 2, and I'm shading everything down this way because x is less than 2. Okay, does that make sense? So instead of doing open and closed circles, we're switching it with parentheses and brackets because that's technically the correct way to write a linear inequality. And that's how Mr. Rice wants us to do it, so that's what we're going to start doing. It's like the introduction way to it, and then this is like, hey, now that you understand some math, let's throw this in here on you. Let's make it more sophisticated so that when we get to harder problems, it just is easier for you to decipher what's going on. What if I want to graph x is greater than or equal to 1? How would I graph that? How would I graph x is greater than or equal to 1? Am I going to use a bracket or a parenthesis? Bracket. And which way is it going to open up? Is it going, I'm going to go to 1 clearly. Is it going to open up to the right or is it going to open up to the left? What numbers make that true statement? Cole says to the right. Cole was correct. So I put a bracket here and I shade everything to the right. Because anything that I plug in that's higher than 1 fulfills that statement. So those are very basic, simple ones, okay? We're going to do ones also where you're going to have more than one on the same bar graph, okay? Or on the same number graph. let's say it says this, graph, and then it says -1 is less than x is less than 2. -1 is less than x is less than 2. Okay? Here's 0, 1, 2, 3, -1, -2, -3. Okay, let's start with this. -1 is less than x. What does that mean if -1 is less than x? How would that? Okay. You have to think backwards. It's telling me -1 is less than x. So that means x is what? Greater. So I'm going to shade to the right because any number bigger than -1 is going to make that statement true. But you are correct that it is a parenthesis. Then it says x is less than 2. So what do I do there? You're going to break it down into two separate segments. X is less than 2. Now I go to 2. Is my parenthesis facing in or out? What is in? Because less than 2. Is 1 less than 2? Yes. Is 3 less than 2? No. So what makes this statement true is everything in between those two parentheses. Everything in that section. Or you can see something written with two separate things, where it says graph x is less than or equal to -2, or x is greater than 1. Why would I have a scenario where I have this or that? What type of graph could that possibly be? Or what type of equation could that include? Does anyone know? What type of equation can you get a positive and a negative answer out? Or you can get two answers out. It has something to do with this symbol. Do you know what this means? Absolute value. If I have the absolute value, I can plug a positive and a negative number in there and get the same thing out, right? Or I could get two possible answers. So that could be one scenario. In this case, it just tells us graph x is less than or equal to 2, or x is greater than 1. 0, 1, 2, 3. Just make it simple. You don't have to put a ton more numbers than you need. Just say that. Let's graph this first statement. X is less than or equal to 2. What does that look like? Bracket at 2, facing that way or to the left or to the right? X is less than or equal to 2. To the left. Yeah, because if I plug in a 1, 1 is less than 2, right? But if I plug in a 2, 2 is equal to 2, so that works. Now, I come over here. X is greater than 1. X is greater than 1. What does that mean? Parenthesis. Which way at 1? To the right. So this is a very small scenario. The only numbers that work are pretty much fractions in between 1 and 2.
Wait, so would x greater than that?
Oh, I'm sorry. It is a parenthesis. You are correct. That's my fault. So I have a parenthesis and I have a bracket. Because I can't plug the number 1 in here, but I can plug the number 2 in here and make this statement so true. Okay? What about... So that is called what we just did is called a compound inequality, consistent of two simple inequalities joined by and or. So these are compound inequalities. Okay. They include the terms and so here it has or. Here this technically is saying and. Okay. -1 is less than x and x is less than 2. Okay. So this stands for and when it's written graph inequalities goes two ways so far. Okay, so tell me what happens when there is one special type of inequality. Okay, something that happens when I solve inequalities. Let's say I have something that says x minus 7 is greater than 4. I have to do what to even graph this first? What do I need to do? Yeah, I solve for x, so I need to do what? Add 7 to both sides, right? And I get x is greater than 11. Okay? That is an addition one. Okay? Add the same number to each side. So this is adding. What happens when I have x plus 3 is greater than or equal to 1? What do I do there? You subtract 3. I subtract 3, I get x is greater than or equal to negative 2. This is subtraction. Okay? Now, this inequality and this inequality and this original inequality are called congruent inequalities or equivalent inequalities. So when it is asking for an equivalent inequality, it means give me an inequality that says the same thing as what I already gave you. These are the same exact thing. I just put it in a form where I can graph it easier. Okay? What happens when you have one like this? 1/2 x, okay, is greater than 10. What do I have to do to solve that? You multiply by 2. I'm going to multiply each side by 2, right? I'm going to multiply this by 2, multiply this by 2, and I get x is greater than 20. So this is multiplication. This is still an equivalent inequality to the above, okay? What happens if I have 5x is less than 10? What do I have to do there? X is less than 10. What do you have to do there? Divide by 5. Okay, I divide by 5, I get x is less than 2. This, once again, here is an equivalent inequality to that one, and this is through division. Okay. What happens if I get this? Negative x is less than 17. What do you have to do to get x by itself there? Negative x is less than 17. What's technically in front of this x? A 1. So what am I going to do? Well, no. It's not just a... What is this symbol tell me? It's negative. It's a negative 1. So you're going to divide by negative 1. What happens when I divide an inequality by a negative number? This sign flips. So, this inequality is congruent to that, or is equivalent to that inequality, but my sign flips. So when you are doing negative multiplication or division, in this case they call it negative multiplication. They multiplied by negative 1 on both sides, technically, right? Okay, when you were doing negative multiplication, the sign flips. Okay? So what happens if I divide by a negative? What if I have negative 9x is greater than or equal to 45? What do I do there to get x by itself? Divide by negative 9, and I would get x is what? less than or equal to negative 5. This is the same, they're still equivalent inequalities, but my sign flips. So a negative division, the sign flips also. Okay, so when I add, subtract, or straight up multiply or divide, sign stays the same, I'm just solving normal. When I divide or multiply by a negative, my sign flips. That's where most people mess up. They forget to flip their sign. Then your answer's wrong. Okay? Don't forget to flip your sign. Okay. Let's go ahead and do an example of a couple of these. And then tomorrow, if for some reason you really struggled with this on your homework, we'll do more. But if not, we can move on, okay? So let's look at this one. 5x plus 2. 5x plus 2 is greater than 7x minus 4. So I want to solve these and graph. And when I graph these, they're going to be on a number line. What do you want to do first? Get what? Okay, which x do you want to move? The 5 or the 7? Which one's larger? I would move the 5 bit. Just because then I won't get negatives. Does that make sense? Okay. So subtract 5x, subtract 5x. I get 2 is greater than 2x minus 4. Now what do I want to move? What 2? There are 2 2's, that's why I'm asking.
Oh, would you?
Okay, if I added 2 over here, is there anything on this side? No, and what do I want to get by itself?
Oh.
I want to add 4 because I want the x by itself. So add 4 and I get 6 is greater than 2x. Now what do I do? Divide by 2. Did I divide by a negative? No, so the sign stays the same. So 3 is greater than x. 3 is greater than x. We're going to graph that. Okay, how do I graph that? 3 is greater than x. Parenthesis, good. Facing the left or right? 3 is greater. Facing the right, because if I plug a 2 in, is 3 greater than 2? No. So I gotta go this way. Always ask yourself that. Plug a number in. Plug a number in to see if you've got it right. 3 is greater than x. Okay. I added 4 and that's 5x. Okay. I was just double checking to make sure math was right because I feel like I screwed something up on it. We subtracted 5x, right? To give me 2 is greater than 2x minus 4. We added 4. And we got 6 is greater than 2x. We divide by 2. 3 is greater than... Oh, wait a second. Oh, you might be right. 3 is greater than x. So I want numbers that are less than x. You are correct. I'm crazy. Cole is right and I was wrong. Yeah, I was thinking this was flipped. So if I plug a number into x like 2, 3 is greater than 2. It makes that statement true. Oh, Cole. Way to be a genius. Okay, there we go. Perfect, Cole. Thank you. Now, what happens if I solve this one? Negative 4 is less than 6x minus 10 less than or equal to 14. Okay, this is one of the ones that's a compound one that says and with it basically. So I'm going to do what first? Here's what I do want to tell you. We want to leave the x in the middle. Okay, so whatever you do, get the x by itself in the middle. Okay, so what do you think I want to do with this here? Add 10. Do I add 10 where? Add 10 over here, and add 10 here. Negative 4 plus 10 is 6. So 6 is less than 6x, less than or equal to 24. Now what do I do?
Did you divide everything?
I can divide everything by 6. That's exactly what I need to do. 6 divided by 6 is 1. 1 is less than x. X is less than or equal to, what's 24 divided by 6?
4.
4. Okay? So now I have a number line. 0, -1, -2, -3, 1, 2, 3, 4. 1 is less than x. So what am I going to do to graph that? 1 is less than x. Parenthesis or bracket. Parenthesis. So I go to 1. Is the parenthesis to the right or to the left? So plug in a number. If I plug in 0, 1 is less than 0. Is that a true statement? No. So if I plug in 2, 1 is less than 2. Is that a true statement? So I want to open it up so that it faces the 2. Now, x is less than or equal to 4. I go to 4, bracket or parenthesis. And is it facing in or out? If I plug in a 2, is 2 less than or equal to 4? Yes. So it's going to face the 2. So everything in there is shaded.